Hello students. So in this video we are going to solve some problems on photoelectric effect. So as we know that photoelectric effect has been explained by Einstein on the basis of Planck's hypothesis, and Einstein has described few terms in photoelectric effect. As you can see on your screens, the first thing is the work function. So what is work function? Work function is a minimum binding energy required for an electron to escape from a particular metal surface. So this energy is been represented by h nu naught. W naught is equal to h nu naught, where nu naught is known as the threshold frequency. So threshold frequency is the minimum frequency below which the electrons cannot be knocked out from the metal surface. Above the threshold frequency, the electrons can be knocked out or can be ejected from the metal surface. The second thing in the photoelectric effect is the law. By applying the law of conservation of energy, Einstein has developed his photoelectric equation, where he has related the kinetic energy of the electron with the frequency of the radiation. So kinetic energy is represented by h nu minus nu naught, or simply you can say that the kinetic energy of the electrons in is represented by h nu minus h nu naught, where this h nu naught is nothing but your work function, and this is h nu is the energy of the incident photon. The another point in photoelectric effect to remember, means to solve the problem, is the stopping potential. Stopping potential is represented by capital V naught, and it is related to maximum kinetic energy of the electron. So kinetic energy maximum is equal to EV naught, where E is known as the electronic charge, whose value is equal to 1.6 into 10 raised to the power minus 19 coulomb. Okay, now we'll look upon the problem number 1. So what the problem says, find the maximum energy of the photoelectron whose the work function and threshold frequency if the potassium surface is illuminated by a light of wavelength 5893 angstrom. The stopping potential for the emitted electron is 0.36 volt. So you have to find out the maximum energy or the maximum kinetic energy of the photoelectron, the work function, and the threshold frequency. So what is given to you, first of all we will write what is given here. So it is given the incident wavelength, means lambda is given to you 5893 angstrom, and the stopping potential, that is capital V naught, is provided 0.36 volt. And what you have to find out, you have to find out the maximum kinetic energy, which is kinetic energy maximum. So we will solve one by one. So mark it as 1. So kinetic energy maximum, as we have seen, it is related to the stopping potential as EV naught. So E is the electronic charge. So you can substitute the value of electronic charge here, which is 1.6 into 10 raised to the power minus 19 into V naught is given to you 0.36 volts. So this term will come out to be in joules. So it is equal to kinetic energy maximum. When you solve it, you will get it 0.576 into 10 raised to the power minus 19 joule. Or instead, if you have to find out it in electron volt, then in electron volt, or it is in kinetic energy in electron volt, is simply 0.36 electron volt. Because you know that the 1 electron volt, as we know that 1 electron volt, this conversion we all know, 1 electron volt is equal to 1.6 into 10 raised to the power minus 19 joules. Now the second thing in the numerical is you have to find out the work function. So work functions W naught is related to threshold frequency, but you need to know threshold frequency, and that too has been asked in the numerical. So other ways to find out the work function in this problem, we know that the kinetic energy is related here. So kinetic energy is equal to h nu minus work function. So work function can be represented in terms of kinetic energy. So work function is equal to h nu minus kinetic energy. All right. So we know the incident frequency or the incident wavelength, which is, and we can easily convert it into frequency can be related to wavelength. So work function can be represented in terms of kinetic energy in this way also. We have work function. We can write instead of frequency hc by lambda minus kinetic energy. So kinetic energy maximum we have just obtained. So you can substitute this value or either this value, but you have to take care about the units. So work function h is a Planck's constant 6.63 into 10 raised to the power minus 34 joule second. So it is in joule second multiplied by c, which is the speed of light, 3 into 10 raised to the power 8 meters per second, divided by lambda, which is 5893 angstrom. So I am converting it into meters. 5893 into 10 raised to the power minus 10 meters. Now if we are using in joules, then we will substitute this value 0.576 into 10 raised to the power minus 19 joules. So here you can say, see, after solving it, you will get the work function is equal to approximately equal to 2.79 into 10 raised to the power minus 19 joules. You can easily convert it into electron volt also. Just divide this joules by 1.6 into 10 raised to the minus 19. Okay, now we have find out the work function. The third part of this numerical is to determine the threshold frequency. So threshold frequency can be obtained from this expression directly. So threshold frequency nu naught is represented as W naught by H. So we have find out the work function. So we'll substitute the value of work function 2.79 into 10 raised to the power minus 19 joules and Planck's constant 6.63 into 10 raised to the power minus 34 joules second. So when you solve it, you will get the frequency is equal to, so you will get the frequency is equal to 0.42 into 10 raised to the power 15 per second, or 4.2 into 10 raised to the power 40 अगर हम इसे significant figures में देखें तो. So this is a very easy problem. So in this problem we have used all the formulas and expressions regarding the photoelectric effect. Now coming to the second problem. The second problem is it possible to liberate an electron from a metal surface having a work function of 4.8 electron volt with an incident radiation of wavelength 5000 angstrom and 2000 angstrom? So in this problem, two incident radiations are provided, 5000 angstrom and 2000 angstrom, and you have to tell कि कौन सी रेडिएशन से पॉसिबल है इलेक्ट्रॉन्स का इजेक्शन होना. ठीक है, अगर उस मेटल का वर्क फंक्शन 4.8 इलेक्ट्रॉन वोल्ट है, तो देयर इज अ कंडीशन इन फोटोइलेक्ट्रिक इफेक्ट that to liberate an electron, to liberate, or you say ejection of electron, ejection of electron from the metal surface from the metal surface can only be possible when the frequency of incident radiation is greater than frequency of threshold or threshold frequency. अगर ये कंडीशन सेटिस्फाई होती है तभी आपका जो इलेक्ट्रॉन है, फोटो इलेक्ट्रॉन है, वो इजेक्ट होगा। तो अब हमारे पास वर्क फंक्शन है, तो गिवन क्या है हमें? गिवन है हमें सिर्फ वर्क फंक्शन। तो हम वर्क फंक्शन से थ्रेशोल्ड फ्रीक्वेंसी पता लगा सकते हैं। अभी हमने प्रीवियस न्यूमेरिकल में देखा था कि वर्क फंक्शन से हमने कैसे थ्रेशोल्ड फ्रीक्वेंसी कैलकुलेट की थी, और वहाँ से फिर हम ये जो 2 फ्रीक्वेंसीज गिवन है इनका कैलकुलेट देख लेंगे कि कौन सा रेडिएशन पॉसिबल है। तो यहाँ से जब आप कैलकुलेट करेंगे तो थ्रेशोल्ड फ्रीक्वेंसी W0 over H. So W0 is given to you 4.8. So 4.8 into 1.6 into 10 raised to the power minus 19 जूल्स में आ जाएगी ये, ठीक है। और प्लैंक कांस्टेंट अब हम जूल्स की ही में रखेंगे, जूल सेकेंड में 6.63 into 10 raised to the power minus 34 joules second. Clear? So when you solve it, you will get the threshold frequency. So your threshold frequency nu naught is, when you solve it, you will get 1.15 into 10 raised to the power 15 per second. So this much threshold frequency you will get. Now the first part where your lambda is given 5000 angstrom. So this much lambda is given to you. So you can write it as 5 into 10 raised to the power minus 7 meter. So you can easily find out the incident frequency for this lambda. Say it is lambda 1, so nu 1 will be c by lambda. C is your speed of light, 3 into 10 raised to the power 8 meters per second, and lambda is 5 into 10 raised to the power minus 7 meter. So your nu 1 will come out to be 0.6. When you solve it, 3 by 5 will give you 0.6 and 8 15 per second. So this new one, you can easily see that this new one is less than 1.15. So we can write that, so this new one is less than your threshold frequency. Okay. So the liberation of electron cannot be take place from with this frequency, with this wavelength. So liberation of electron cannot take place. अब क्वेश्चन का सेकेंड पार्ट देखते हैं। तो क्वेश्चन का सेकेंड पार्ट है कि लैम्डा 2 इज इक्वल टू, सपोज 2000 ये आपको दे रखा है, 2000 एंगस्ट्रॉम which is equal to 2 into 10 raised to the power minus 7 meter. So you can find out nu 2 again by c by lambda. So when you substitute it and get the answer, what you will get, it is nu 2 is 1.5 into 10 raised to the power 15 per second. So this 1.5 value nu 2 is greater than your threshold frequency. So electron liberation can take place with this much of wavelength. So from here you can conclude your answer like this. With the wavelength 2000 angstrom, the liberation of electron can take place with this much of work function.